Good morning, everybody. Today we meet at the 2021 International Conference on Nuclear Safety. Here, I will present our research topic about the new hybrid cryptographic methods to enhance the data communication security on instrumentation and control system at nuclear facilities. Ladies and gentlemen, the background of this research began when the Master Terminal Unit (MTU) and Remote Terminal Unit (RTU) in SCADA, or Supervisory Control and Data Acquisition, are spread over different areas. Communication between devices in SCADA is in the form of data transmission over the Internet using a protocol called the DNP3 protocol, which makes the data transmission easy to get cyber attacks, in this case interception attack. And then the vulnerability of data transmission through the DNP3 protocol is still in the form of original transparent data or plain text, further opening the vulnerability and potential for interception attacks. In addition, this research is also motivated by the incident that some time ago we heard the news of the Stuxnet malware attack on Iran's uranium enrichment facility in 2010, which caused the uranium enrichment process to fail, and the industrial attack on a Ukrainian power company in 2017, which caused the nationwide blackout. Based on this explanation, it is necessary to increase security by increasing the randomness value of the transmission data so that it is secure from interception attack. What is the research problem? In the existing DNP3 data transmission system or the running system, the transmission data is still in the form of original data or plain text. So the level of randomness of the data is zero or none at all, thus causing data transmission to be insecure and weak against cyber attacks in the form of interception attacks. This study aimed to increase security by increasing the randomness value of the transmission data by adding the VRC4 superencoding methods, a combination of VGener and RC4 encoding, which is equipped with 4 symmetric and dynamic key generators that are random every session, which produce highly random ciphertext data. Previous research features several studies on improving security in SCADA system in general, as well as research on increasing security in the DNP3 protocol. Furthermore, research on increasing data transmission security from several infrastructure. Interestingly, several studies on increasing the security of SCADA and the DNP3 protocol have used cryptographic methods. However, data communication device must provide communication with a strong or sufficient capacity to secure data transmission to prevent cyber attack, including applying cryptographic methods aimed at increasing the randomness of the transmission data. Therefore, this study built a combination of encoding to increase the randomness value of the transmission data so that it is secure from interception attack. This is gap analysis that presents a comparison of several previous studies, including this research. So, what exactly the contribution of the research? The first contribution is build a hybrid cryptography method VRC4, which is a combination of VGener and RC4 encoding, which aim to increase the randomness value of transmission data, which is higher where compared to only using VGener or RC4 encoding, to that it's become more secure. And next, the following contribution is that the key generation is carried out for time in layers or for dynamic symmetric key generators to increase the value of randomness, thereby increasing the security of data transmission. The method follows the defense in-depth aspect or layer defense that need to be implemented in computer security policies and instrumentation and control system in countries with nuclear facilities. This research is motivated by several incidents of cyber attack on industrial control systems. That is due the vulnerability of network protocol connected to the internet. Meanwhile, the available network protocol do not provide adequate security features. These cyber attacks will intercept data transmission via a network protocol. To overcome these cyber attacks, we introduced the data transmission security using Vigener RC4 hybrid cryptography. We propose hybrid cryptography Vigener RC4 by combining Vigener and RC4 cyber and combining the dynamic symmetric for key generators. We can see the feature above on slide shows the proposed model, the securing data transmission using the Vigener RC4 hybrid cryptography methods. The proposed model consists of two main processes, i.e. the encoding process at the data sender and the decoding process at the data receiver. From the figure, we can see the red arrow line describes the process of sending data on the existing system where the RTU sends insecure plain data when requested by the MTU. In comparison, the proposed model describes securing data using super encoding to produce cyber data. Then the cyber data is sent to the MTU. This process is shown in the green arrow line. When received at the MTU, the cyber data will have decoding become the plain data as before. If the encoding process at the MTU, which consists of Vigener encoding of new IL data using the key to key, produces a Vigener zipper, then proceed with RC4 encoding using the K4 key to produce a Vigener 4 cipher. Next, the decoding process after the VRC4 cipher is received at the MTU, which is the reverse process of the encoding process. The system decode RC4 on the VRC4 cipher using the K4 key and generate Vigener cipher, and then the system decodes Vigener using the key to key, and finally generate new EL data. The following shows some of the new EL data which result from the VRC4 decoding process on the left, and new EL data before going through the VRC4 encoding process on the right. Let's pay attention together when compared to the result on the left and the result on the right are exactly same. This indicates that the VRC4 decoding process has succeeded in restoring to plain data as before. Histogram analysis aims to compare the distribution deviation between plain text and ciphertext data. The key space of initial key K1 with a length of 256 bytes or character is 2 to the power of 2048 bits, meaning that the proposed method is secure from brute force attack. Correlation analysis aims to determine the level of correlation or relationship between plain text and ciphertext data. The correlation value get closer to zero, meaning that the two data are getting random, and the more difficult it is to find similarities. The result of the calculation obtained the correlation value as shown in the table. Entropy is the randomness measure of the amount of information in a message. The entropy value is closer to 8 and data is getting random and more secure. The calculation result obtaining the entropy value which show that the VRC for proposed method has a higher randomness value than only Vigener or RC4 alone. Since the entropy value is getting closer to 8, the data get more random and more secure. Conclusion. The size of the K1 key space is 2 to the power of 2048 bits, meaning it is secure from brute force attack. The system uses K1 to generate K2 and then generate K3 and K4, so the final key is getting random. The correlation value for the VRC4 method is closer to 0 compared to only Vigener or RC4 encoding. The entropy value for the VRC4 method is closer to 8 when compared to only Vigener or RC4 encoding. It shows the VRC4 method is more random than only Vigener or RC4 encoding alone, which means it has succeeded in increasing security. Suggestion. Transmission data randomness value with a correlation value close to 0 and entropy value close to 8 can be considered as technical requirement related to regulation, policies, procedure, or guideline on data security transmission over the internet following the IAEA Nuclear Energy Series on computer security aspect of design for instrumentation and control system at nuclear power plant. Thank you for the attention.